Anxiety and Depression, the Neurobiology of the Mind's Hidden Storm. A professional medical narrative by Meds Insights. The invisible weight. It often begins quietly. A racing heart for no clear reason. Sleepless nights that blur into restless days. A sense of heaviness that words can't describe. At first, you think it's just stress, but soon you realize the tension never leaves. Your body is tired, your mind is louder than ever, and every day feels like surviving another storm inside your head. That storm is anxiety and depression, two intertwined disorders that have silently reshaped the modern world. But what truly happens inside the brain when we feel anxious or depressed? Why does our own mind, designed to protect us, sometimes turn against us? To answer that, we must journey into the neuroscience of emotion, the biochemistry of mood, and the pathophysiology of mental suffering. The biology of emotion, understanding the brain's triangle. In the center of our brain lies a powerful emotional control center called the limbic system, home to three key players. The amygdala, our alarm system, detecting threats. The hippocampus, our emotional memory bank. The prefrontal cortex, our rational control center. Together, they form what scientists call the emotional triangle. In a healthy brain, these regions communicate seamlessly. The amygdala detects danger, the hippocampus recalls context, and the prefrontal cortex decides what's real or imagined. But in anxiety and depression, that harmony breaks down. The amygdala becomes hyperactive, firing alarms even in safe environments. The hippocampus, overloaded with cortisol, begins to shrink, weakening memory and perspective. And the prefrontal cortex, the voice of reason, goes offline, unable to calm the chaos below. What remains is a body stuck in survival mode and a mind that no longer feels safe. Anxiety, when the alarm never stops. Anxiety is not simply worry. It is a biological overdrive of the body's stress response system. At its core lies the HPA axis, the hypothalamic, pituitary, adrenal system. When your brain perceives danger, the hypothalamus releases CRH, corticotropin-releasing hormone, triggering the pituitary to release ACTH, which then signals your adrenal glands to release cortisol and adrenaline. These chemicals prepare you for battle. Heart rate increases, muscles tighten, blood sugar rises, pupils dilate. In short bursts, this response keeps you alive. But when it stays active, day after day, week after week, it transforms into pathological anxiety. Chronic cortisol floods the system, causing fatigue, digestive issues, and impaired immunity. Neurons in the hippocampus begin to die, impairing memory and increasing confusion. Meanwhile, the amygdala grows larger and more reactive, meaning the longer you live with anxiety, the more your brain learns to stay afraid. That's why anxiety often feels uncontrollable. It's not just a mental habit, it's a rewired brain loop. Depression, when the light fades inside. Now imagine the opposite, a brain no longer overreacting, but shutting down. That's depression, the biochemical counterpart to anxiety. It's not sadness, it's neurochemical depletion. At the cellular level, depression involves disrupted signaling in the monoamine system, primarily serotonin, dopamine, and norepinephrine. Serotonin regulates mood, appetite, and sleep. Dopamine drives motivation and reward. Norepinephrine maintains alertness and focus. When these neurotransmitters fall out of balance, whether from genetic vulnerability, chronic stress, or inflammation, the circuits that create joy and motivation fall silent. Neuroimaging shows that depressed patients often have reduced activity in the dorsolateral prefrontal cortex, responsible for planning and decision-making, and increased activity in the subgenuate cingulate gyrus, an area linked to emotional pain. Even the brain's architecture changes. The hippocampus shrinks, dendritic connections thin, and neurogenesis slows. This explains the emotional numbness, slow thinking, and memory loss many patients describe. In short, depression is a disconnection disease. Neurons stop communicating effectively. The biochemistry of stress and mood. To understand why both anxiety and depression coexist, we must examine the chemical messengers that shape emotion. When stress is chronic, the sympathetic nervous system dominates, releasing norepinephrine, cortisol, and adrenaline. These hormones were meant to protect us, but prolonged exposure desensitizes brain receptors and triggers inflammation. In the microglia, the brain's immune cells, this causes an inflammatory response, releasing cytokines such as IL-6 and TNF-alpha, which interfere with serotonin synthesis and block neurogenesis. So in essence, prolonged stress doesn't just affect mood, it physically changes the brain. It reduces brain-derived neurotropic factor, a protein that helps neurons grow and connect. Low BDNF levels are consistently linked to both major depressive disorder and chronic anxiety. That's why antidepressants like SSRIs take weeks to work, not because serotonin acts slowly, but because the brain needs time to rebuild the connections that were lost. Body connection: why the heart, gut, and brain speak the same language. Patients with anxiety and depression often report physical symptoms: heart palpitations, stomach upset, headaches, and fatigue. This isn't coincidence, it's neurophysiology. The vagus nerve, which connects the brainstem to the heart and gut, carries emotional signals in both directions. When the brain is distressed, it alters heart rate variability and gut motility. When the gut microbiome is disrupted by poor diet, antibiotics, or inflammation, it sends distress signals back to the brain. This gut-brain axis is now a frontier of psychiatric research. Studies show that serotonin, the happiness chemical, is mostly produced in the gut, not the brain. So a healthy mind literally begins in a healthy gut. Genetics and environment: nature meets nurture. Why do some people crumble under stress while others remain resilient? Part of the answer lies in genetic polymorphisms. For example, variants in the 5-HT-LPR gene, which controls serotonin transport, can increase vulnerability to depression after trauma. But genes are not destiny. Epigenetics, the chemical tags that turn genes on or off, play an even larger role. Chronic stress increases DNA methylation of mood-regulating genes, silencing their protective effects. Yet, through therapy, exercise, meditation, and supportive relationships, those same genes can be reactivated. This is neuroplasticity in action, the brain's ability to heal itself. Treatment: rewiring the brain. Treatment is not just about symptom relief, it's about restoring biological balance. Psychotherapy. Cognitive behavioral therapy, CBT, targets distorted thought loops in the prefrontal cortex and helps it reassert control over the amygdala. Mindfulness meditation strengthens gray matter density in emotional regulating areas. Exposure therapy retrains the fear circuits through repeated safe experiences. Pharmacotherapy. SSRIs, like sertraline or fluoxetine, increase serotonin availability at the synapse. SNRIs affect both serotonin and norepinephrine for dual action. Atypical antidepressants like bupropion enhance dopamine transmission, improving motivation. In severe resistant cases, ketamine and transcranial magnetic stimulation, TMS, show promise by rapidly increasing BDNF and synaptic connectivity. Lifestyle medicine. Regular exercise boosts endorphins and promotes neurogenesis. Omega-3 fatty acids improve neuromembrane fluidity. Adequate sleep normalizes cortisol cycles and consolidates emotional memory. Even small daily habits, hydration, sunlight, breathing, have measurable neurochemical effects. The path to healing: restoring balance. Recovery from anxiety and depression is not a straight line. It's a gradual recalibration of the brain's rhythm. The nervous system must learn safety again. The prefrontal cortex must reclaim leadership. The amygdala must unlearn fear. With consistency, therapy, and biological support, the brain rebuilds itself. Neuroplasticity is real. Dendrites regrow, circuits reconnect, neurotransmitters rebalance. Healing is not about returning to who you were. It's about becoming who you were meant to be once the noise is gone. Conclusion: the science of hope. Anxiety and depression are not flaws in character. They are malfunctions in circuitry. They are the echoes of a brain that has endured too much, too fast, for too long. But neuroscience now shows something extraordinary. The brain that breaks can also rebuild. Synapses can heal, emotions can stabilize. Hope itself can become biological. So if you or someone you love is fighting this invisible battle, remember this: the storm is not permanent. It's a process your brain is trying to survive. And with understanding, science, and compassion, we can help it find calm again. Meds Insights: educating the mind, healing the world.